Hello and welcome back to Get Great at Maths. I'm here to help you pass your maths exam, so hit that like and subscribe button. We're going to look at keywords, key formulas and how to gain top marks. So let's get ready to get great at maths. We're going to be looking at key facts to do with sequences, and in particular two different types of sequences, linear sequences and quadratic sequences. Now linear sequences can be called arithmetic sequences. These two terms mean exactly the same thing. At GCSE, we generally tend to use the word linear, and at A level, we generally use the word arithmetic, but they mean exactly the same thing. So when we have got a linear or arithmetic sequence, it means that your sequence goes up or down by the same number. So you've either got an increasing sequence or a decreasing sequence. And you will be asked to work out the nth term. And to do that, you'll need to find the common difference. So you'll have to find the gap between each of the terms. Quadratic sequence is harder, and to find our quadratic sequence, we need to find the second difference. So when you find the first difference of the sequence, it won't be the same number. So you have to go again and find the second difference. And if your second difference is the same, that means you have got a quadratic sequence, and that means it will involve an n squared. So that is the difference between the linear and the quadratic sequence. The linear sequence will involve an n, and a quadratic sequence will involve an n squared. We're going to start off by looking at some pattern sequences, and from this sequence that you can see here, we're then going to build up to calculate the nth term of a sequence, and you can see where everything links together all from this start sequence. So you can see I've got a pattern here, they're forming L shapes, and you've got to work out the next pattern. So pause the video, see if you can get yourself a pencil and a ruler and draw out accurately the next diagram that will appear here next. Press play when you've got an answer. Fantastic, so hopefully you've managed to spot that each of these L shapes is getting bigger. So there's one added on the top here and one on the right, another one added on the top, another one added on the right. So the sequence you should have drawn should be the pattern looking like this, where you've got 1, 2, 3, 4, 5 squares up, and including the same square, you've got 1, 2, 3, 4, 5 going across. So make sure you have drawn out the diagram correctly. Next, I would like you to work out how many squares there are in each diagram. So please write this down next to each of the diagrams. How many squares have you got in each of the diagrams? So press pause while you have a go at doing this, then press play when you've got yourself an answer. Fantastic, so you should be able to see on the first one we've got 1, 2, 3 squares. The next one I've got 1, 2, 3, 4, 5 squares. Then I've got 1, 2, 3, 4, 5, 6, 7 squares. Then I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 squares. So this is my sequence, and this is a linear sequence that we're going to be looking at, and we'll explain why it's a linear sequence shortly. So remember our key facts here for the linear and the quadratic sequence. So I've got 3, 5, 7 and 9 is my sequence. What are the next two terms of this sequence? Again, press pause, work out the next terms of the sequence, and then press play when you've got yourself an answer. Fantastic, so hopefully you've managed to come up with the answers 11 and 13. But why? Why did you get the answers 11 and 13, and what does it mean in relation to these diagrams? So press pause, have a think about why the answer was 11 and 13 and how your answer that you've got links to these diagrams. Press play when you've got yourself an answer. Fantastic, so hopefully you've managed to come up with an answer, and you should have spotted that these numbers here are going up in twos. So because they have got the same difference between them, it means it is a linear sequence. So we are adding on 2 every time. So to get from 3 to 5, I add 2. To get from 5 to 7, I also add 2. And from 7 to 9, I also get 2. Now sometimes in the exam they will say why, and other times they will say what is the nth term, and you need to be able to distinguish between what it's asking you to do. So make sure you read the question carefully. Now we're going to look at this and these diagrams and see what this +2 is actually representing. Now, when we looked at finding the next term in the pattern, we mentioned that we added a square on the top and on the side. So each time you added one on the top and one on the side. One on the top, one on the side. That is why it's plus 2, because every time this common difference that we found is adding on 2 extra squares. So you add one on the top and one on the side. So diagrammatically, that's what that plus 2 is representing, the extra 2 cubes being added into the diagram. So make sure you understand how this plus 2 links to this diagram. Often the question will be either a diagram or in terms of numbers, but they may link it like this. So make sure you can clearly see how your diagram links to what is happening. We're now going to look at the steps to find the nth term for a linear sequence. So our first step is to find the common difference. And if you get a common difference, which I'm going to call D, that means we have got a linear sequence because the first difference is the same, like we just saw in the sequence we were looking at. Next, we've got to work out the D times table. So if it was the 4 times table, we would write down the 4 times table. 4, 8, 12, for example. I've just generalised here in terms of D. You don't have to do that. You will just be working with numbers. And if you write it above the sequence, then it makes it easier to see the difference between them on our next step. The third step is the first term of the nth term is going to be D lots of n. So we've just worked out our common difference to be D. So that means my sequence will start off with D times by n. And then to work out what number goes on the end of the sequence, you have to work out how to get from the D times table to the number in the times table for each sequence. So in this case, I'm just going to say it's plus A. To find that from the times table to the number in the first sequence, it is the same as working out the difference between the common difference and the first term of the sequence. I will show you how both of these work. Personally, I prefer to use this one down here because it is quicker, but this is why it works, so I'm going to explain both so you can see. So our nth term will be looking something like this, so in the form of dn plus a. So you'll have some number before an n with a number written on the end. That is how you find the nth term of a linear sequence. We're now going to look at finding the nth term of the linear sequence, which is linked to the diagram we started off earlier. So remember, it had this pattern of 3, the L's forming this pattern, and we're going to find the nth term. We already know that the sequence goes up in 2s, which means we have got 2 lots of n because our common difference is 2. So the beginning of the nth term is going to have 2n at the front, which means we need to be looking at my 2 times table. Now the 2 times table is written up here, 2, 4, 6, 8. We now need to look at how do I get from the 2 times table to the numbers in the question. So what do I do to each of these numbers to get the number underneath? So you should be thinking, to get from my 2n, because this is double what we started with, the n numbers. So to get from 2 to 3, all we have to do is add 1. Now that is exactly the same as taking the sequence, finding out the first difference, sorry. So the first difference was 2. What do I do to 2 to get to 3 is plus 1. That is the same way of getting the answer of plus 1. So you don't actually need to write out the linear sequence above. You can just go from here. There's a little shortcut going from here. What do you do from 2 to get to 3? You add 1. It's personal preference if you write this bit out, or you just go from here. I don't mind which way you do, as long as you can get the answer. So the nth term is this bit here combined, the 2n plus the 1. So here is my nth term. Remember this 2 linked to this diagram here. So this was my common difference. These were the 2 parts we had. Now this plus 1 on the end, okay, is the difference between the common difference and the first term. So between 2 and 3 is plus 1. And diagrammatically, what that represents is this square here. So this is the extra plus 1. So on all the L shapes, there was always a corner piece, and that's what this plus 1 is representing. So sometimes in the exam, you'll need to explain why. Often it is just calculate the nth term or work out the 50th term or work out different term values from within there. but that's how we work out the linear nth term. Here are some practice questions for you to try. Press pause, have a go at working out the nth term for each of these sequences, and then press play when you've got an answer. Well done. Hopefully you've managed to get yourself pencil, pen or whiteboard or whatever you're using and get yourself some answers here for the nth term. So you need to look at each of these terms and work out the common difference. So here between 5 and 9 is plus 4, 9 to 13 is plus 4, 13 to 17 is plus 4. So it's going up in fours, which means we have got 4n. Now what do we have to do to 4 to get 5? We add 1. So our first term is 4n plus 1 because it's going up in fours. And then to get from 4 to 5, we add 1. The next sequence here, you need to work out the difference between each of the terms going along. So if you're unsure of what the difference is between 19 and 8, if you do 19 take away 8, that gives you 11. 30 take away 19 is also 11, and 41 take away 30 is also 11. So that means we have got 11n at the front. Now to get from 11 to 8, this time we've got to subtract. So 11 take away 8 is 3, so our sequence is 11n take away 3. Because we do 11 times 1 is 11, take away 3 gives me the 8. For the second term, 11 times 2 is 22, take away 3 gives me 19. The third term, 11 times 3 is 33, take away 3 is 30. The next sequence you can see isn't ascending, so these two sequences here are ascending, which means they're getting bigger and they're going up. This sequence here is descending. So this time when the sequence is descending, that means the number in front of the n is going to be negative. So I'm going down now, so each time I've gone from 9 to 6, I'm going down by 3. So take away 3, take away 3, take away 3, which means I'm going down in threes, which means I've got a 3n at the beginning. Now I've got to get from negative 3 all the way up to 9, and this is where people make a mistake because you're going from negative 3 over here all the way up to plus 9. And to get from negative 3 to plus 9, you've got to go from negative 3 to 0, which is plus 3, and then you've got to go from 0 to 9, which is 9. So it's the total of these numbers here. So it is going to be negative 3n plus 12. It's very tricky to get this plus 12 on the end, and a lot of students find that really difficult to get the plus 12 because they will just do plus 6 on the end because they'll go from 3 to 9 is a difference of 6, not from negative 3 to 9. If you didn't get this one correct, press pause now and then have a go at this one and see if you can do this one before I give you the answer. Well done. So hopefully we've managed to come up with an answer for this one. Again, you can see this is a decreasing sequence. So you can see that we're going down, and if you do 25 take away 19, you get an answer of 6. So each time we're counting down in sixes. But again, we've got to go from negative 6 because we're going down in sixes all the way up to 25, which is our first term here. So how do I get from negative 6 all the way up to 25? Well, from negative 6 to 0 is 6, and from 0 up to 25 is 25. So I've got to do 6 plus 25, which gives me 31, which is the number on the end. So my formula is for the nth term is negative 6n plus 31. Give yourself a score out of 4, and big tick and smiley face if you got 4 out of 4. You've done really well. Well done. We're going to look at the steps to find the nth term of a quadratic sequence. So when we're doing a quadratic sequence, you will find that the second difference between the terms is the same. Once you've calculated the second difference and they are the same, you have to halve that value, and that will give you the n squared coefficient. Now this word coefficient here is the number in front of a letter. So in this case here, it's the letter B, so it's B lots of n squared. Now normally when you write a quadratic, you would probably start with the letter A, but because when I did the linear sequences, I used A earlier, I'm keeping with the same form, so I've just called it B, the next letter in the alphabet. So find the second difference. They need to be the same. If they are the same, halve that value, and that will tell you how many n squared you've got. you've got to subtract the quadratic from this original sequence. So work out what this value here is. So if it's just n squared, you'll need to work out your square numbers. If it's 2 lots of n squared, you'll need to double all your square numbers. If it was 4 lots of n squared, you'd have to multiply all your n squared numbers by 4. So you've got to work out what that quadratic is going to be, and you're going to subtract that from the original sequence, basically the question. Then the remainder that you get, or the answer, is going to be a linear sequence. So that is how we work out the nth term of a linear sequence that we did earlier, and you've got to work out this linear sequence on the end, and then combine them together to get your quadratic in the form bn squared plus dn plus a. So this is the quadratic part, which find by the second differences. You will get 1 mark for finding the second differences in the exam and halving it. Then find the linear sequence on the end will give you another mark, and combining it for the final mark is where you get your marks from in the exam. So you're looking for something like this. It is quite tricky to find the quadratic sequence, but if you follow through these steps, I assure you that you will be okay and you'll get to the right answer. We're looking at the nth term of a quadratic sequence. So here's an example. I'm going to show you how we calculate the nth term of this quadratic sequence. Now, initially, by looking at the sequence, you probably don't know it's a quadratic sequence. I'm telling you it's a quadratic sequence because that's what we're looking at here. But to know it is a quadratic sequence to start with, is we've got to find the differences. So if I look at the difference between 6 and 9, it's plus 3. Between 9 and 14 is 5. So again, if you did 14 take away 9 gives you 5. 21 take away 14 is 7. So the differences between these are 3, 5 and 7. They are not the same. If the numbers were the same here, it would be linear. But because the numbers here are not the same, it is not a linear sequence. So we need to go again. So the difference between 3 and 5 is 2. And the difference between 5 and 7 is also 2. Now these numbers are the same, which means we have got a quadratic sequence. Once I've got this number here 2, I have to halve it. Now halving that number, half of 2 is 1, which means I've got 1n squared at the beginning of the sequence. Now to find the nth term, the easiest way is to draw yourself out a little table. So you've got the term number, which is n, so you've got the numbers 1, 2, 3, 4, which are these numbers up here, 1, 2, 3, 4. First term, second term, third term, fourth term. We write down the original sequence, which is written here. And then I'm going to work out n squared. Now, n squared are my square numbers. So your square numbers I've written down here for you. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. And 4 times 4 is 16. They are square numbers. Once we've got these numbers here, the original numbers, which was the question, the n squared, which I've worked out from here, I've written in the table, I'm going to subtract these. 6 take away 1 is 5. 9 take away 4 is 5. 14 take away 9 is 5. And 21 take away 16 is also 5. These numbers along here, these remainders are all the same. Now, because they are all the same, that means my quadratic nth term is going to be this n squared here plus this number here, because it is exactly the same. So the n squared plus 5 is my nth term. So for example, if n was 1, 1 times 1 is 1, plus 5 gives me 6, the first number of my sequence. If n is 2, 2 squared is 4, plus 5 is 9, the second term of my sequence. So this is how I work out the nth term for a quadratic sequence when all the remainders are exactly the same. You're going to practice a couple of questions now, and then we'll move on to the next level, which is the hardest level that there is. Once you've mastered that, then you've nailed quadratics. I've got 2 practice questions here for you to find the nth term of. So question 1 and question 2. Here's the example we've just worked out up in the top left-hand corner. Your key facts are down here with your square numbers to help you. See if you can work out what the nth term is for these 2 sequences. Press pause, get yourself pen and paper, or write on your computer or device, and then press play when you've got an answer. Well done. Hopefully you've managed to come up with the quadratic sequences for each of these. Feel free to pause the video at any point where you need to take more time to process what I'm saying. So we're going to start off by finding the differences. So finding the differences, I've got 9, 12, 17 and 24. So 12 take away 9 is 3, 17 take away 12 is 5, 24 take away 17 is 7. Working out the second differences, you will find they are all the same and they are 2 as we would expect. We take this second difference, which is 2, and halve it. Half of 2 is 1, which means we have got a 1n squared. You need to draw yourself out a nice little table here with the numbers 1 to 4 along the top. You've got the original question, which is what we're going to write in on this line here. The n squared is your square numbers. So 1 squared was 1, 2 squared 4, 3 squared 9, 4 squared 16, and then we're going to subtract these two answers here to get your remainder. So 9 take away 1 is 8, 12 take away 4, 8, 17 take away 9, 8, 24 take away 16 is 8, and this gives me the nth term of being n squared plus 8 because we've got the n squared up here. These are all the same, so this is plus 8. Give yourself a big tick if you got that correct. Press pause if you haven't had a go at question 2 yet. Have a go at question 2 before you hear how to do it. So again, we're going to start off here by finding the second difference. So I've got a difference of 6, 13 to 23 is 10, 23 to 37 is 14. The second difference is here, I'm going to have a difference of 4 and a difference of 4 again. So my second difference is the same. I take this number and I halve it. So half of 4 is 2, which means I have got 2 lots of n squared. We copy the table out again, writing out the question in the top line here. And now I have got 2 lots of n squared. So the numbers that I had here, I've basically got to double. So doubling 1 is 2, doubling 4 is 8, doubling 9 is 18, and doubling 16 is 32. I'm going to subtract the original numbers, take away 2n squared. So 7 take away 2 is 5, 13 take away 8 is 5, 23 take away 18 is 5, 37 take away 32 is 5, which means my answer is 2n squared plus 5. So combining the 2n squared here plus the answer here gives me the final nth term. Give yourself a huge tick if you got those correct. You've done really well. Well done. We're going to look at an example of finding the nth term of a quadratic sequence. So you can see our sequence here, and when you look at it initially, you would not know that that was a quadratic sequence. So to identify that it's a quadratic sequence, we need to look at the differences between the terms. So if we look at the difference between 6 and 13, we can see that it is 7 because 13 take away 6 is 7. Then the difference between 13 and 22 is 9 because 22 take away 13 is 9. And the difference between 22 and 33 is 11 because 33 take away 22 is 11. From here we can see that these differences are different. So because the first differences are different, that means we do not have a linear sequence. So we now need to look at the second differences. So the difference between 7 and 9 is 2, and the difference between 9 and 11 is also 2. The second differences are the same. So these two differences are the same, which means we have got a quadratic sequence. So that's how we identify it as a quadratic sequence. Now to work out how many n squared we have got to take the second difference, which is 2, and we're going to halve it. So half of 2 is 1, which means we have got 1 lot of n squared. So this sequence is going to start off with n squared. So the nth term will start off with n squared. To work out the rest of the values, we've got to do a table. So my n terms go along the top. So this is my first term, my second term, my third term, and my fourth term. So the original sequence gets written in the top. So this is the question. So along there, 6, 13, 22, and 33. And then we've got to work out n squared. Now n squared are my square numbers. So 1 squared is 1. 2 squared is 2 times 2, which is 4. 3 squared is 3 times 3, which is 9. 4 squared is 4 times 4, which is 16. You can see I've written the square numbers out here in the bottom right-hand corner. Once we've got these two bits of information, we need to subtract them. So this is working out point 2, subtracting the quadratic from the original. So here's my original. I'm taking away the quadratic part of it, the n squared. So 6 take away 1 is 5. 13 take away 4 is 9. 22 take away 9 is 13. 33 take away 16 is 17. You can see now I've got a sequence which are different numbers. So these numbers are no longer the same. So last time all these numbers were exactly the same. This time these numbers are different. And these numbers here form a linear sequence. So 5, 9, 13 and 17 have all got a common difference. So if I work out the difference between 5 and 9, it's 4, because 9 take away 5 is 4. 9 plus 4 is 13. 13 plus 4 is 17. So they have got a common difference of 4, which means my sequence here is going to be 4n. So we're looking at finding the nth term of a linear sequence here. So these blue numbers are my sequence, and I've got to work out the nth term of these blue numbers. So it's going to be 4n because the sequence goes up in 4. As the difference is 4, I've got to look at 4, and what do I do from 4 to get to 5? So 4 plus 1 is 5, which means 4n plus 1 is the equation for the linear sequence here. So 5n, 5, 9, 13, 17 follow the sequence 4n plus 1. Because 4 times 1 is 4, plus 1 is 5. N is 2, 4 times 2 is 8, plus 1 is 9. N is 3, 4 times 3 is 12, plus 1 is 13. And the same will happen for 4. So 4 times 4 is 16, plus the 1 is 17. So that's how this sequence works. To make the full quadratic nth term, we have to take this part here, the n squared term, plus this linear sequence here and combine them to get the nth term. So your final nth term is n squared plus 4n plus 1. So that is how we work out the nth term for a quadratic sequence. It is really tricky stuff, but once you've got the method and you understand what's going on, it always follows the same method. You will get there and you'll be able to get the answer. So just persevere and you can do it. Just keep trying, and I've got a few questions for you to try. We're now going to look at some practice questions on finding the nth term. So you've got two sequences here. You need to find the nth term of these two sequences. There's an example here in the top right hand corner here for you to use to help you work out what the nth term is. So the answer you're trying to work out is this one here in the star, like the first example, n squared plus 4n plus 1. That's what you're trying to find an equivalent for these two questions. Press pause, get yourself a pen and paper, have a go at working out the answer, and then press play when you're ready to hear the answer. Well done. Hopefully you've managed to come up with some answers, and feel free to pause the video at any point and then press play when you're ready to hear the next steps as we go through. So to start with, we're going to look at the differences between the terms. So the difference between 4 and 12 is 8, between 12 and 22 is 10, and between 22 and 34 is 12. These differences are different, so we now need to find the second differences. So between 8 and 10 is 2, and between 10 and 12 is also 2. The second differences are the same, which means we have got a quadratic sequence. And to find how many n squared we've got, we take this 2 and halve it, and it will tell me I've got one lot of n squared. So we're always halving the second difference. So I've got n squared. Once we've got that value for n squared, we need to draw out the little table where you've got the original number, the n squared and the remainder, and the numbers 1 to 4. The original is the question, so the question gets written at the top. N squared are our square numbers which are written over here. So I've got 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. I now need to subtract these because this is what step 2 says. So we're going to subtract these two values. So 4 take away 1 is 3, 12 take away 4 is 8, 22 take away 9 is 13, and 34 take away 16 is 18. From here, I have got a linear sequence. We've now got to work out the nth term of this linear sequence. So from 3 to 8 is 5, from 8 to 13 is 5, and from 13 to 18 is also 5. So this is going up in fives. So I've got 5n. Now, to get from 5 to the first term here, which is 3, 5 take away 2 is 3. So the nth term of this linear sequence is 5n take away 2. Once we've got the nth term of the linear sequence, I combine it with the number I've got here, or the term I've got up here, and the final answer for the nth term is n squared plus 5n take away 2. Now press pause if you haven't managed to do question 2 yet, and make sure you have a go at doing it before I go through the answer. Give yourself a big tick if you got that correct, so fantastic work, well done. Next, we're going to look at this sequence here. So we've got 5 to 10 is a difference of 5, 10 to 19 is a difference of 9, and 19 to 32 is a difference of 13. Differences are different, so we've got to look at the second differences. So 5 to 9 is 4, from 9 to 13 is 4. So the second differences are now the same. So we take the second difference, which is 4, and we halve it. Half of 4 is 2, so I've got 2 lots of n squared. Again, I draw out the table, and at the top values, I write the original numbers down here, and then I write down my n squared numbers, but this time I've got to times them by 2 because it's 2 lots of n squared. So the numbers I had here, I've basically got to double. So double 1 is 2, double 4 is 8, double 9 is 18, and double 16 is 32. I now need to subtract these numbers from each other. 5 take away 2 is 3, 10 take away 8 is 2, 19 take away 8 is 1, and 32 take away 32 is 0. Again, all these numbers are different, but this time the numbers are decreasing, so that means they are going down. Each number is going down by 1, which means I've got negative 1n because it is going down by 1 each time, and I need to know how to get from negative 1 to 3. So from negative 1 to 3 is going to be plus 4, so my linear nth term here is negative n plus 4. So that's step 3, working out the remainder as a linear sequence. Then step 4 is joining these two parts together, and my final answer will be 2n squared take away n plus 4, and that is how we work out the nth term of a quadratic sequence. Give yourself a big thumbs up and a big tick if you've managed to get that correct. You've done really, really well, so well done.